right, so what do people get for an answer? What's that? 11, 61. Tiffany, what was yours? Oh. Another 61. 61. Okay. So we multiplied. Those don't look like they should give just 61 as an answer, do they? Because it's two complex numbers. It looks like we should probably get some other complex number in the answer. But where I'm going with this problem is these are actually what are called conjugates. It's like our difference of two perfect squares. They match except the sign's different. And when you multiply, they're called complex conjugates just because they're complex numbers. When you multiply complex conjugates together, you get a real answer. So you have to FOIL this. Try that again. So we get 6 times 6 is 36. 6 times negative 5i is negative 30i. 5i times 6 is positive 30i. And then 5i times negative 5i is negative 25i squared. And Muna, your mistake would have just been a sign. So what do I replace all of my I squareds with? Negative 1. So this last term is negative 25 times negative 1, which turns to plus 25. How about the middle two terms? Negative 30i plus 30i. Cancel. It's just like our difference of two perfect squares. Those are gone. So really I just have 36 plus 25. 61. So we're going to use this idea when we divide complex numbers. Now, dividing complex numbers is nothing more than multiplying. So if you understood the multiplying that we did at the end of class, dividing is the exact same thing. You're just going to multiply the numerator and the denominator of our fractions. Fractions show division. So whenever we set up division of complex numbers, it's going to be set up like a fraction. What we're going to do is we're going to multiply by a form of 1 that actually makes the denominator into a real number, so we get just one complex number in the end. It's kind of funny to think about, but when you look at your answer, it's like, okay, that makes sense. So we're going to use this idea here for our binomials. Again, it looks like the difference of two perfect squares, and what happens when you have a complex number and you multiply by its conjugate, that's what that's called, is a conjugate, you get a real answer. So what we're going to do is we're going to first talk about the conjugate for different denominators, and then our division problems are nothing more than multiplying. Division problems are nothing more than multiplying. So to find our conjugate, all we're going to do is take our complex number. What's the form of a complex number? What's our answer look like for a complex number always? It's got two parts to it. Real part, imaginary part. Complex number is always in the form a plus bi. That's what a complex number looks like. Our directions always say to leave in the answer a plus bi because that's the form of a complex number, which I think is one of the questions on your last extra credit, which turn in on Friday if you're still doing that. Now, the conjugate, it's actually called a complex conjugate just because it's a complex number. All you do is switch the sign on that plus bi. So all you're going to do is look at your imaginary term and switch the sign. If there's a real term out front, it stays the same. Now, right here in our first example, a is actually a complex number. This first one here is a complex number. What's the real part? It's kind of a trick question. This whole thing is bi. If I want to write this as a plus bi, what could I add to something without changing its value? 0. You multiply by 1. You add 0. So this is really a complex number. We just don't write the real part because it's 0. To change it, to get its conjugate, all we do is change the sign on the imaginary term. So instead of positive 7i, it's going to be negative 7i. So if I look at b, this would be in my problem my original denominator. To find its complex conjugate, all I do is take the imaginary term, switch the sign. So a complex conjugate of 3 minus 2i is 3 plus 2i. So if you can remember to change one sign and you know how to multiply, you can divide. So if my original denominator, we're always going to be going on denominators. If our original denominator was negative 9i, what's the complex conjugate? So my imaginary term, just change the sign. Positive 9i. So if my original denominator was 5 plus 8i, my complex conjugate, 5 minus 8i. So what we're going to do for our division problems. So you'll see our division problems are always set up like fractions. So this first problem is a real number divided by an imaginary. This next one's a complex number divided by another complex number. It's always set up as a fraction. We don't ever do division. What we're going to do is we're going to multiply by our conjugate, and it's going to give us one number for our answer, one complex number or one real number. When we get down to these fractions that look like they're all compact, we're also going to talk about you always have to have a very distinct real half and a very distinct imaginary half. Never this one big kind of mess, but we'll see that in several problems. So when I'm asked to divide complex numbers, the first thing I need is to figure out what my complex conjugate is. And this is always for the denominator. So if my denominator is negative 5i, what's my conjugate? 5i, positive 5i. You just switch the sign. So what I'm going to do is I'm going to take my complex conjugate and I'm going to put it into a form of 1. It's the only thing we can multiply by, so we don't change the value of our original fraction. But we should see happen, it's very similar to the idea of rationalizing where we get rid of the square root in the denominator. What we should see happen is we should see that this denominator now turns back to be real. It's kind of our goal. Just like when we rationalize, we're trying to get no square root in the denominator. When we divide, we're trying to get no complex numbers in the denominator. So let's start with the numerator. What's 6 times 5i? 30i. And then how about negative 5i times positive 5i? Negative 25, I or I squared? I squared, so both have I. But what? We don't leave I squareds in our answer. I can replace that I squared with a negative 1, so I'm looking at 30i over 25. Notice our denominator is real. Am I ready to box that answer, you think? Yeah, you can reduce the numerical part of that fraction. You can reduce that 30 over 25. So I can divide them both by 5. 6 over 5. Now, I tend to leave my i's in the numerator. The way you're going to see it in the back of your book is probably 6/5 and then the I off to the side. They mean the same thing. The only thing that would be different would be I in the denominator, which we don't want. So you can either put the I in the numerator or the I right next to it. And you may be looking at, I always get people who look at the original problem and look at our answer and are trying to make up, okay, the shortcut is I change the sign, I move the I. There's really no shortcut. That looks like that for that one particular problem, but as soon as we get to B, your shortcuts are out the window already. So no shortcut, just multiply by the conjugate. So for B, I always find the conjugate for the denominator. So my denominator is positive 7i. What's my conjugate? Negative 7i. Just change the sign of the imaginary term. It's the only term there. Now I'm going to multiply by my conjugate, both the numerator and denominator, because I've got to use a form of 1 since we're working with an expression. Now my numerator is a binomial. Put all those binomials into parentheses. So it looks like, now you can, personally I would just say, okay, binomial times a monomial, what are we going to have to do? Distribute. So you can go back, or if you need to rewrite it so the negative 7i is first, you can do that as well. But you've got to distribute. So we're going to start with 6 times negative 7i, which is negative 42i. And then negative 3i times negative 7i. Positive 21, and then I squared. And then my denominator is 7i times negative 7i. Negative 49i squared. So we've got some cleaning up to do here. First thing I would recommend when you're simplifying is replace all of your I squareds. Go through, find all of your I squareds, and replace them with negative 1. So this is 21 times the negative 1. This is negative 49 times negative 1. So I have negative 42i minus 21 all over positive 49. So now we've got all of the elements of our answers, but we've got that same direction. Simplify to the form a plus bi. What do I do, Alicia? Yeah, that's one you absolutely could. So we talked about simplifying 3-term fractions before. So you see there is a GCF to all 3 of these terms. Yeah, oh, all those terms come back. You could absolutely do that now. I would probably do that now. We'll also be breaking it apart, so if you don't remember how to do that, you don't have to worry because we have another way to simplify this. So other than simplifying the fractions, which I'm going to do last, but this is a great time to do it if you see that GCF of 7. What else is wrong about the way this problem's kind of put together? Yeah, the order. We always need the real half first, the imaginary half second. Well, in our numerator, the imaginary is first. So what we've got to do is we've just got to flip-flop these two. So I have negative 21 minus 42i. The other thing you don't want in your answer is you don't want one big fraction that's a big mix of real and imaginary. So all I have to do to fix that is write each of these over 49. It's always okay to split up a numerator. You can't do that with a denominator, but I need to see real, imaginary. I don't want to see real and imaginary all together in one big fraction. I need them separate. So all you do to separate them is give the real part its own denominator and the imaginary term its own denominator. And now if you hadn't seen before, what Alicia said where I said, oh, I could just divide them all by 7, just simplify the real fraction and then simplify the imaginary. So now I could simplify negative 21 over 49. I can divide those both by 7. I get negative 3/7. And then I can simplify the 42 over 49. Again, I can divide them by 7. So it's going to be minus 6/7 I. And again, the I could be part of the numerator or it could be beside. But you see, my real fraction is negative 3/7. And then the BI is the negative 6/7 I. You've got the very distinct real and the very distinct imaginary. Questions? So dividing, find your conjugate, multiply in a form of 1. So for C, I have 3 plus I over 2 minus 3i. So this one's going to be a little bit more work. So we've got those complex numbers in the form a plus bi. It's your definition of a complex number. It's got real plus imaginary. So first thing, where do I find my conjugate, numerator or denominator? Denominator. So my original denominator is 2 minus 3i. So what's my conjugate? 2 plus 3i. Again, it looks like a difference of two perfect squares. You just switch the sign in the middle. So I'm going to multiply by 2 plus 3i over 2 plus 3i. But they each have two terms. Parentheses, 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 parentheses. So what am I going to have to do to multiply those numerators together? FOIL. Now, I don't usually work the FOILs out kind of all in line. I'm going to work the FOILs out on the side and then just put my answers back together. So let's work out the numerator. So my FOIL is going to be 6 plus 9i plus 2i plus 3i squared. So this is what we did last time. If you can do what we did last time, you understand how to find a conjugate, you can divide. I always start by replacing my I squareds with a negative 1, so that last term is negative 3. I can combine the two terms that both have I, they work just like x. So 9i plus 2i is 11i. And then I'm going to combine my real terms. And your steps might not look just like this, that's okay. So I got my numerator is going to be 3 plus 11i. Now, the numerator can be anything. We have expectations for the denominator, though. What do you think the denominator should work out to be? Not what number, just kind of generally. What do you think is going to happen when we multiply those two together? It's going to be a real number. It's going to be a single real number. That's our expectation. So when we did our warm-up today, I had you multiply these two together, and we got a single real number. That's what you expect to happen in these division problems, is that your denominator becomes a single real number, no matter how ugly what we're foiling is. So I'm going to get 4 plus 6i minus 6i minus 9i squared. And what should happen every time you're multiplying these denominators together, middle two will cancel. So I'm almost free of i's. What else do I need to do? That negative 9i squared is negative 9 times negative 1. It's positive 9. So I just have 4 plus 9. Just me 13. So now I've got to put my answer together. I can't just leave those two separately. That's the denominator. How many denominators do you think I'm going to have in my answer? 2. I'm going to have one for the real half and one for the imaginary half. So I'm just going to put the 3 over 13 and the 11 over 13. So that I see real, imaginary, completely separate. So go ahead and try D. Try D, then we'll get that up, and then I have some review problems for you. All right, what's my conjugate? What's my conjugate for this problem? 2 minus I. So just take the denominator. I do CC because it's a complex conjugate. That's what the CC stands for. So 2 minus I, and then I saw everyone was, even if you didn't write it, you were going through and doing your multiplying. Really, we should put everything in parentheses. So 6 minus I times 2 minus I. Starting with my numerator. So a lot of 12. And then the negative I just says it's a positive times a negative. So negative 6I. Same thing here, negative I times positive 2 is just negative 2I. And negative I times negative I is positive I squared. Now these I squareds that hang out by themselves can be a little bit trickier, but for the most part you guys got them. So I replaced just the regular I squared with a negative 1. If you put plus a negative 1, it's mathematically the same thing. Middle 2 make a negative 8I, so I'm looking at 12 minus 8I minus 1, which is 11 minus 8I. Real half first, imaginary half second. And then what's our expectation for our denominator? What should the denominator work out to be? Real number. So that's one way that you can see if you got the right conjugate. If you don't get a real number for your denominator, something's wrong in your problem. So when I FOIL these, I'm going to get 4 minus 2I plus 2I minus I squared. And I didn't get as many of you as I usually try to get with this problem. Minus I squared. It's got a minus sign out front, and then what goes in place of the I squared? Minus 1. So a negative, negative 1 turns into positive 1. And I couldn't get many of you with that. The negative sign in front of the I squared isn't the same as the negative sign that comes in with the 1. You got two negative signs. That's positive. Middle 2 will cancel. That's how you know you're doing this right. So 4 plus 1 is 5. So I just take each of these and write them over 5. If you want to do one big answer and then split it, that's fine. It's just an extra step. So I have 11 fifths minus 8 fifths I. Question.